The topic is selection sort, and this is the n square algorithm. It comes under comparison based sorting. I have taken a list of elements. I have to sort them. Why the name selection is taken, we have to understand that. So while explaining the procedure, I will tell you what is the meaning of selection. So let us start the procedure. This algorithm also sorts the element in passes. In each pass, one element will be sorted. Just like bubble sort and insertion sort, for n elements, n-1 passes are required. So let us perform first pass. From that we will learn everything about selection sort. So let us perform first pass. From that we will understand the working of selection sort. Now for sorting these elements for the first pass, I will take this list vertically. So I will write the elements. So I have a list ready here. Let us perform first pass. In first pass, we will select first position to find out an element for that position. So I repeat, I stress on the point, we select a position. Yes. So let us take I here. Select a position. I is pointing on a position, that is index 0. Now who should come at this place? The smallest element in the list should come at that place. So find out minimum element. Find out whichever element is minimum. So for finding out minimum element, we will take 2 pointers, K as well as J. 2. Both of them will be on the same position wherever I is pointing. Now let us see how to find out minimum. Move J to the next element and check whether this is smaller than where K is pointing. Yes. So bring K at this place. So J will find out minimum element, and if any element is found, it will bring K there. Continue. J moves to the next location. J is pointing on this element. Is it the element smaller than where K is pointing? Yes. So call K here, ask it to stand here. This is the smaller element we found. Then move J to the next element. J is here. Is it smaller than the element where K is pointing? Yes. So call K here, ask it to stand here. We got a still smaller element than where you are pointing. Now J moves to the next element. Is it smaller than the element where K is pointing? No. Move to the next location. Is it smaller than the element where K is pointing? No. So don't move K. Continue. Next element. Now J is at index 6, so it is out of the list. So we have finished the entire list and found out a smallest element where K is pointing. So just observe one thing. Just we found out which is the minimum element and we got its index. We have not swapped any elements. We did not swap any element. Right. Then interchange the element from I to K. Then the new list will be 263, 854. So 8 is brought in place of 2 and 2 is sent there. So 2 and 8 are interchanged. Now this is the result of the first pass and this element is sorted. First element is sorted. So in one pass we got one element sorted and that is the smallest element in the list got sorted. We got the smallest element in the list. So what we did is we selected a position, that is first position, that is index 0, and found out an element for that particular position. So we got a smallest element for that position. Now this was the first step, first pass. Continue same thing. Perform second pass. So quickly I will perform remaining passes. This is second pass. First element is already sorted. Now select the next position. So I will be pointing here. Now take J as well as a K also here only. J and K there only. Right? Then using J find out the element that is smaller than this 6. Is it smaller than that 6? Index 2, right? We are on index 2. Yes. So bring K also here. Then move J. Is it smaller than 6? No. Is it smaller than 6? No. Is it smaller than 6? No. J has finished the list. So finish the list means we got the smallest element. What is that? K, that is index 2, that is element 3. Interchange. So these two elements will be interchange and the new list will be 2, 3, 6. These are interchange and A54 as it is. So these two elements are sorted. Now let us perform third pass. Take I on index 2, that is third element, because already two elements are sorted. I is here, and make J as well as K, both of them point there only. Now start using J to find out the element that is smaller than this. Is it smaller than that? No. Is it smaller than that? Yes, 5 is smaller than 6. So bring K here. Then continue. J, is it smaller than where K is pointing? Yes, 4 is less than 5. So bring K here. So end of list. And we got a minimum element at index 5. So interchange these two. Then the new list will be 2, 3. This will interchange. So here 4. Then 8, 5, 6. Now three elements are sorted. Next we have to select a fourth element, that is index 3. We have to sort this one. We have to find an element for this position. So K and J will be pointing there only. Find out a smaller element. Is it smaller than that? Yes. So bring K here. Is it smaller than 5? No. So list ends. So this is the smallest element in this list. Interchange these two. So the list will be 2, 3, 4, 5, 8. These are interchange and 6. So these four elements are already sorted. Now only two elements are remaining. Then select next index 4 and find out the smallest element for that position. So start K as well as J. Then J is here. Is it smaller? Yes. So bring K here and end of the list. Then interchange. K is here, so it is interchange. So the new list is 2, 3, 4, 5. This two will interchange. So 6, 8. This was fourth pass and this was fifth pass, and this is the result of the fifth pass. All elements are sorted. We sorted total 5 elements, but the sixth element will automatically get sorted. I'll separate it so that you can see it clearly. So total 5 passes. The last thing is sorted order. So once again, we were selecting a position and finding the element for that position. It is just like, imagine there are some students in a class and this is the first seat in the class. I have to find out who should sit here. So I selected the seat and finding out who should sit here. Okay, I'll ask the student to come and sit here. Maybe based on height, based on the marks, or based on roll number, whatever it is. I'll select a seat and find a student who should sit here. So we selected a position 0, that is first position, that is index 0, and find out which element should come there. So in the entire list 2 was minimum, so 2 was brought there. That's it. So selecting a position, finding an element. Now let us do some analysis. Find the number of comparisons and number of swaps. See, in first pass we compared almost all elements. So total 6 elements are there. So 5 comparisons we have done. So comparisons were 5, and number of swaps. How many swaps we have done? We have performed just one swap. Remember this, one swap. And here at most 4 comparisons and just one swap. And here 3 comparisons and just one swap. 2 comparisons, one swap. 1 comparison, one swap. So if you observe the comparisons 5, 4, 3, 2, 1. So total number of comparisons I will write down here. Number of comparisons 1 plus 2 plus 3 plus goes on. For n elements, how many comparisons will be there? N minus 1. So this will be n into n minus 1 by 2, and this is order of n square. So we have already done this type of analysis in bubble sort and insertion sort. Here also it is same. Number of comparisons are n square, so the time is n square. Then how many swaps? In each pass just we are performing just one swap. So number of swaps are, for n passes, n minus 1 swap. So it is order of n. Yes, this is more important about selection sort. For n elements, only n minus 1 swap, so order of n swaps. So this is the only algorithm which sorts the elements with minimum number of swaps. See, to avoid swaps, we have taken j as well as a k. We find the index. Once we found the index, then we interchange. Will not be interchanging every time. So we can avoid interchanging of elements with the help of extra variable k. So selection sort is good for less number of swaps. Next, one more important thing about selection sort. See, if I perform only one pass, then what I get? Smallest element. If I perform just two passes, then what I get? Two smallest element. So it means if I perform k passes, k number of passes, then I get k smaller elements. So yes, just like bubble sort, there we were getting k largest element. In selection sort, we get k smaller elements. So intermediate results of selection sort are useful. Now next is, we have to check whether it is adaptive and stable or not.